previous problem where we had, scroll up here, multiplication becomes addition. So again, this is just another property here. So it's log base 2 x cubed minus log base 2 square root of yz, like that. You just separate them out as shown here. Is that okay? Is that clear?
Yeah.
Okay. All right. Now the thing on the right here, this square root of yz, that's where you've got to remember that if you have the square root of something, it's really that something to the 1/2 power. So this on the right here is really yz to the 1/2 power, like that. Is that okay?
Yeah.
So now we're going to use that property where if you have x to the n, that n comes out in front. This equals n log x. So that exponent in both cases is going to come out in front. So it's going to be 3 log base 2 of x minus 1/2 log base 2 of yz.
Okay.
But there's a bit more here because this yz right here is a product. Okay, and this is kind of the thing you would see on a test here. So if you have the log base 2 of a times b, it becomes log base 2 of a plus log base 2 of b. You have a product becomes a sum. So sometimes, and they're labeled this way, like it's product to sum, and then quotient to difference. I don't know that the words are all that meaningful here, but maybe they're better for you if they are, go with that. But the product becomes a sum. So on the right here, it's 1/2 log base 2 y plus 1/2 log base 2 z. Okay, but it's really all in parentheses. And this is the thing that you see on a test or quiz. You have to remember to distribute this negative to both terms. Okay, so minus 1/2 log base 2y minus 1/2 log base 2z, 3 log base 2x. And that's your final answer. We'll get a chance to practice this on number 13. But any questions on this or anything you want clarity on?
No, it's pretty straightforward, actually.
Yeah, you have to know all these properties on the right that I keep writing down. I'll keep writing them down. You just have to know them. There's no way to do this without it. Okay, so number 13 here, I've snipped in for us to look at. What do you think here? Which property do you think we should use first when you look at this thing?
It's log a over b equals log a minus log b, right?
Okay, so you can definitely use that, but I want to draw your attention to this 4 right here. I would probably move the 4 in front first and then apply that property. But the order actually does not matter. If we do it the way you suggested, which is fine, you would have to write it this way: 12 times 5 to the power 4 minus log base 3, 11 to the 6 to the power 4. So do you think you would have remembered to do that, to put those exponents there?
No, it's just better to do it first.
Yeah, probably better to do it first. Now, but there are times when it's better to do the quotient first. So it's not like every rule works all the time for this. So actually, let me put those like that. So there you go. So now we can break it apart as a difference. So it's 4 log base 3, 12 times 5 minus 4 log base 3, 11 to the power of 6, like that. All right, so now for the next part here, you can, the 12 times 5, yeah, you could multiply that, but the idea is to expand here. So it's going to be 12 plus 4 log base 3 of 5. You treat the 12 as an A and a 5 as a B. On the right, you can bring that 6 out in front. Now it's multiplying. Okay, so you might get to this step and think you're done. 4 log base 3 of 12 plus 4 log base 3 of 5 minus 24 log base 3 of 11. And you're not quite, you're 80% of the way there. This 12 right here, 12 can be broken down. 12 is actually, 1 times 12, 2 times 6, 3 times 4, and some other things. Now, why am I doing all this? Because of that 3 right there. Because you can break the 12 apart into 3 times 4. And I don't know if that was the intent on this one, because usually it just becomes a prime number. But the reason that matters is now you can break it apart into 4 log base 3 of 3 plus 4 log base 3 of 4. Okay. Plus 4 log base 3 of 5 minus 24 log base 3 of 11. All right, now for this first one, there's another property here. Whenever you have the log base b of b, whenever the base is the same as the thing you're taking the log of, that's always 1. So this becomes 4 times 1 plus. Now you could actually do a little bit more here with the 4. I'm probably going way too far into this, but this is possible. Keep writing the rest here. So that 4 can be written as 2 squared. So that 2 can come out in front with the 4. So it becomes 8 log base 3, 2, and then there's a 4 out in front here. 4 log base 3 of 5 minus 24 log base 3, 11. I guess in the past you've had the answer key, so maybe you can look at it and see what the instructor wants. Really comes down to what they want.
Yeah, he doesn't need it like all the way simplified. His final answer was 4 log of 3, 12 plus 4 log of 3, 5 minus 24 log 3 of 11.
So all the way back here, right?
Yeah.
Yeah. Yeah, I mean, I would argue that you should go further, but you should give the instructor what they want in this situation. Okay, so so now that you know how to expand, the next type of problem is to condense. Condense here. So I'm just grabbing the next question, and you essentially undo the rules that we've been doing. Okay, and there is kind of an order to doing them in. It's kind of like solving versus simplifying. So generally you use you do product. You'll do a product first, or a quotient first, and then you'll do the power rule third. But when you're and that's if you're expanding. But when you're condensing, you do them backwards. So you generally would do the exponent rule first, and then either the quotient or the product rule next. So this one here, like if you see a number out in front, you want to move that exponent up first. So log base 7u plus log base 7v plus log base 7w to the power of 4. Is that okay?
Yeah.
Okay. And then you should recognize, okay, there's a sum. Sum becomes a product. So this becomes log base 7 u times v times w to the 4th. And you're done.
So when there's 3 different ones and both of the signs are addition, then that's when you know to put it in the parentheses.
Well, so addition means it goes in the numerator in general. And then if it's subtraction, it goes into the denominator. We'll maybe see that in an upcoming problem here.
So since they all share a log of 7, you take that out and then you put it in front, and then the remaining things are in the parentheses.
Yes.
Okay.
Okay, so let's look at 16. Maybe you could try this one on your own. It's very much related to the one we just did. So let me snip that in. And then I probably need to give you one that's more like a test question if there's not any others on here, because we're missing kind of a couple of important things. But take a look at that one, see if you can work that one out here.
So would it be log of 6 parentheses u to the power 4 times v to the power 20 times w to the power 4?
Yes, that's correct.
Okay.
All right, so the one we're missing here, I need to make one up here, something like this: 2 log base 3 of x minus 4 log base 3 of y minus 6 log base 3 of z. So I mentioned above here, if it's subtracting, it goes in the denominator. But before you even do that, you need to move the exponents in all three of these. So it'd be like log base 3 x squared minus log base 3 y to the 4th minus log base 3 z to the 6th, like that. Now, if you want an explanation for why the subtractions go in the bottom, I can give you that, or we can just accept the rule as is.
How come the y goes on the bottom?
Okay, so let's look at this line right here. So watch the following. I'm going to take out a negative from both of the second term and the third term. So it's minus log base 3 y to the 4th plus log base 3 z to the 6th. So now inside parentheses here, you've got a log a plus log b situation, which becomes log a times b. So it becomes log base 3 y to the 4th z to the 6th. Bring this one down. And now you've got a log a minus a log b, which becomes log a over b. So everything on the right, y to the 4th z to the 6th, is going to go on the bottom. Log x squared y to the 4th z to the 6th, like that. That's why most students prefer to say, okay, if it's negative, it goes on the bottom. If it's positive, it goes on the top. I apologize if you can hear any of that background noise.
Oh no, you're good.
I can make it go away. So that so you see it's a lot of writing potentially. Sometimes you can just sort of see it.
I think expanding is more difficult than condensing, though.
Yeah,
Because
I mean you're gonna get.
condensing just has the rules for condensing are a lot more simpler than expanding.
So when you condense, you're always going to get one logarithm at the end. All of your answers have one logarithm, always, 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 always. You're going to get one condense and one expand on your test. That's fairly standard. All right, so we can move on if you're ready.
Yeah, I'm ready.
All right. Does your exam cover more than what you sent me today?
No, this is pretty much it. Well, there's other stuff, but I already know how to do them. Like use a calculator to solve this log. That's pretty easy.
Okay. All right, very good. All right, so here's a problem, and this type of problem is where you have log of something equals log of something, and notice the bases are the same. That's very important. So if the bases are the same, you can set the part inside the log equal to each other. But it's only because the bases are the same. Now, this is not being formal. If you needed a formal sort of like, how did you do this? But this is the net result. When the logs are the same on both sides, you can just set the inside parts equal, and then you solve for the variable.
So the logs cancel out.
Yes, I mean that's the net effect of it. So I'll add 5k to both sides, add 8 to both sides. So that's 3k equals 6, divide by 3, so k is 2. Now you are supposed to check your answer. You might think, well, why should I do that? Well, sometimes there are extraneous solutions. So we take this number and we put it back into the original again. This one has an interesting situation here where the answers are the same, but you cannot take the log of a negative number. There's actually maybe this was not known to the person who made this.
It says the answer is no solution.
Right, but we want to know why there's no solution. So you end up getting negative 12 equals log base 15 negative 12. They're the same though, but big but here, log of x is only defined for x greater than 0. So the number inside parentheses has to be greater than 0. And that's why you check, because you got a number. You're like, oh, okay, equals 2. I'm happy. Then you get your grade back and you're like, why did I miss the entire question? Because you didn't check. You got to check. But you got to know what you're checking for. And that's the issue here. All right, let me know when we can go on to 21.
I got it.
Got it down. Okay. All right, so log base 4, x plus 10 minus log base 4 of 3. So this is different. The previous problem had a log equaling a log. This one has 2 logs on the left equaling a number on the right. So your goal here is to turn this into the log of something equals a number. And on the left here, this is why you learn those properties. You have to condense the logarithm. So this is an A minus B problem. So a difference becomes a quotient, log base 4, x plus 10 over 3 like this, equals 1. So that part has to be super clear. You got to realize, okay, I got to condense it, and hopefully it works out the way you want. terms of the condensing, like you get it. You're like, all right, I can do that.
Okay, got it.
All right, so now this is where it's a little bit more, I think we did this last time. There's a little bit more work here. You have to rewrite this as an exponent. So we did this, I think we did this last time where we rewrote like something like this: log base b of x equals n because x equals b to the power of n. Did we do that?
Yeah, we did.
Okay. Now there's another way to do it. So like the answer is, here's the answer. The answer is 4 to the 1 equals x plus 10 over 3. Yeah, but maybe that's not clear. That's a little, so we'll just put that off to the side for now. So what you're really doing is you're raising both sides using 4, this 4 here, as a base of 4. That's the formal way to do this. And on the right, it's the same thing, 4 to the power of 1. Now on the left, there's this property. I should have been doing my properties on there because when you have base to the log base b of x, this always becomes just x. So when the base of your logarithm is the same as the base of this number to the exponent, it becomes just the inside part here. And that's effectively what you're doing over here on the right, but this is the like formal way of doing it. So it becomes x plus 10 divided by 3 equals 4 to the power of 1, which is 4.
You just multiply by 3.
Yeah, so we solve this equation, multiply both sides by 3, you get x plus 10 equals 12, subtract 10, x equals 2, but you need to check. So you go back to the original, and you put that 2 in for x. Wherever you see an x, well, there's just one x there. Okay. So it's log base 4, 2 plus 10, minus log base 4 of 3. So this is log base 4 of 12 minus log base 4 of 3. And you're supposed to decide if that equals 1. Any idea how to do that from here?
The log of 4s cancel out, right?
Well, they will have, if you combine them, you can condense this. How do you condense a difference?
Difference is division.
Yes. So it becomes log base 4, 12 over 3. Still not 1, but maybe we're getting closer. 12 divided by 3 is 4. Is that 1?
Yeah.
Yeah, it is. So that's how you show that your answer is correct. It's not just to say, yeah, it equals 1. All right, so I think I should either give you some more problems or you should you should say, hey, Matthew, I got some more that I want us to work on.
I have one more thing that I forgot to send to you.
Okay. Yeah, why don't you send it over and then we can decide if we want to do some other problems.
I just sent it.
I'm just waiting for that to come in. All right, here we go. Just going to download so I can rotate the picture. Yeah, so these are very different. These are exponent questions. I mean, they're related, but they're very we've done nothing like this thus far for today. But all right, so here we go. We got 5 times 11 to the minus 8x equals 80. So your goal, what you're really trying to do is you're trying to get into some form like this, like a to the x equals a number. Basically, you want to isolate, in this problem, the 11 to the minus 8x. So you undo by dividing by 5 on both sides. So 11 to the minus 8x equals 16. Is that okay? Is that clear?
Yeah.
Great. Now there's a couple of ways we could work the problem from here, but it says to round your answer to the nearest 10,000th. So that means you're going to use your calculator at some point, and not quite yet, but you will eventually use your calculator. And so because of that, we're going to use the following approach. To get a variable out of the exponent, use ln, natural log. Have you seen that in class?
Yeah.
So what you do is you write the natural log of both sides of the equation. And you'll do this in other classes. That's why I'm showing you this technique. So with the natural logarithm, it has the same properties as the log-based b that we were using in the previous problems, meaning that this minus 8x, this exponent right here, minus 8x, it can come out in front. So we bring that out in front. So it's minus 8x natural log of 11 equals natural log of 16. Is that okay?
Yeah.
Clear? Okay. Now, your goal is to solve for x. And it just looks complicated because maybe you're not used to seeing these things. But if you divide both sides by minus 8 natural log of 11, on the left, everything cancels. Minus 8's cancel, natural log of 11's cancel. All you have left over is the x. X equals natural log of 16 over minus 8 natural log of 11. Now, in terms of entering this here in your calculator, what kind of calculator are you using? A TI 8384? 84. Now, you might have a fraction in yours. If you don't, you have to put an extra parenthesis around the bottom because the calculator doesn't know that you want to divide all of that.
I got negative 0.144.
Okay, so you're rounding the nearest 10,000. That's 4 decimal.
1445.
Yeah, 4 decimal place here. Let me get. Yeah, minus 0.1445. Yeah. All right, so we'll look at the next one. 28 is very similar. Just a few different operations, but okay. So we're trying to solve for m, and m is in the exponent. So you want to undo this plus 8 first. You're going to subtract 8 from both sides. Subtract 8, subtract 8. 4 to the minus 5m minus 5 equals 74. Now it's just like the last problem. To get the variable out of the exponent, you're going to use natural logarithm. ln of both sides. And then you bring that exponent out in front. Now it's in parentheses. That's maybe you're going to write it in parentheses. That's maybe what is a little bit different. It's minus 5m minus 5 natural log of 4 like this. if you don't write it this way, you may end up getting a different answer. It's really implied as being in parentheses up here as well. So now to solve for m, you're going to divide both sides by natural log of 4. So it's up to you if you want to write it in parentheses. I guess I go back and forth depending on where it is in the problem. Okay, and then from here you're going to add 5 to both sides, and then you're going to divide by -5. So this one's a little bit more of a headache to put into the calculator, but it's doable. So instead of dividing by -5, you can multiply by -1/5, and that will potentially make this easier to answer. So go ahead and give that a shot, putting that in your calculator.
I got -1.1606. We're to round up to 0.7.
I got -1.606209.
Yeah, yours is the correct answer.
Yeah. So in terms of how you enter this in the calculator, again, it's just a little bit of a headache here, but you maybe go like this: -1/5 parentheses ln74 close parentheses / ln4 plus 5, like that. Now, if your calculator is like a fraction thing, that would be good to look good.
Oh wait, we're gonna put a parentheses. Let me see if that works. Yep, I just got your answer.
Excellent. All right, so where should we go from here? Do you have some more problems for us to look at? Do you want me to find some for you to try to solve, talk through?
Can we do more problems with expanding? Because I feel like that's the one I need to know the most.
Yeah, so you should want to do some expand problems. Absolutely. Okay, so here you go. I'll give you one here. Expand the following. Let's say it's log base 5 x y squared over the square root of z, all to the power of 3. Give that one a try.
Is that y square root of 2 or y square root of z?
Square root of z.
Okay. So far I have 6 times log of 5, parentheses xy, minus 3 times log of 5, parentheses square root of 2.
Okay, let's start. Did you move the exponent first?
Yeah.
Okay, so that gives you 3 log base 5 of xy squared over the square root of z, like that. That's the first move here. Is that okay? I mean, did you get that far?
Yeah.
Okay. Now I would look at this as a quotient. So I would go 3 log base 5 xy squared minus 3 log base 5 square root of z. Okay, and then I would rewrite the square root of z as z to the 1/2 power.
Oh, yeah, I forgot to do that.
Yeah, now this may be more difficult than you'll see on a test or quiz, but it's something that I think comes up at this part of the course. So it's 3 log base 5 xy squared minus 3 log base 5 z to the 1/2. Okay. Now on the right here, you can bring that 1/2 in front. So that becomes minus 3/2, like that. Now on the left here, it's a product. It's a product inside parentheses, so the product becomes a sum. 3 log base 5x plus 3 log base 5 of y squared. And again, you can move that exponent out in front. So it's 3 log base 5x plus 6 log base 5y minus 3/2 log base 5 of z.
Can you go any further from that?
That's it, because there's no exponents and there's only a single term inside there's only a single letter or number inside there.
Okay.
All right, so let me give you another one, if that's okay. So let's go log base 2, 11 times 37 over the square root of 19 to the power of 2.
What would you do with the 11 times 37?
It's a product. Products become a sum.
No. Oh, so it create another one, right?
What do you mean? What do you mean by that?
Well, it'd be 11. It's 11 times 37, so it'd become 2 log of,
yeah.
right. Yeah.
Let's make sure you brought that one out, the 2 out front. Okay. Now from here, it's a quotient. 11 times 37 minus 2 log base 2 of square root of 19. Did you get this far?
Yeah.
All right, so from here, like that square root of 19 becomes 19 to the 1/2 power. On the left here, it's a product, so it's 2 log base 2 of 11 plus 2 log base 2 of 37. So on the right here, what do you do with this 1/2? What does this 1/2 become? Where does it go?
-2/2, which becomes -1.
Perfect. Yeah. So 2 log base 2 11 plus 2 log base 2 of 37 minus log base 2 of 19. Where do you feel like you're stumbling on this problem?
Well, I just forgot that when it's multiplication, then it becomes addition.
Yes. Yes, that's there's the multiplication, there's the quotient. You got to know both. All right, so we got time for at least one more problem, maybe more. What do you want us to look at next? Do you want another expand problem?
Can you do one like 28?
Yes, let me go back and figure out what 28 was. Yes, okay. 3 to the minus 2x minus 4 plus 7 equals 25. And if you have questions, please ask here. How are you doing on this one?
I'm doing pretty well. I'm entering it in my calculator now.
Great. Let me know what you got. You come up with minus 3.3155.
Hang on. Yeah, that's exactly what I got.
Fantastic. Just a small just a small thing to get that in the calculator is make sure you parentheses in all the right places, maybe do the calculation twice. But if you understood all this, you probably do pretty well in your exam tomorrow.
Mm-hmm.
All right. Well, thank you again for letting me reschedule with you. So it's rare when I have to do that, but occasionally that does happen. And I hope you enjoy your holiday, safe travels, and see you after Thanksgiving break.
Yeah. Happy Thanksgiving.
Thank you.
Thank
Yeah,
you.
you too. Okay. Bye now.
Bye.